Good day everyone and welcome to this lesson. Today we'll be going through a question 2 type question for grade 11. This is the way in which question 2s are asked in grade 11. The questions might differ, but the range in which they are asked and the difficulty will be similar. So when you're answering these type of questions, the most important thing that you have to note down is the way in which you answer them. Your approach of answering the questions is very important. You should try doing things step by step. If you rush and try to do everything at once, you might get caught up somewhere and get stuck. But if you do something one by one, then you'll be able to unfold it easily and it will give you an easier way to understand it. And I promise you, this trick will never fail. Try to do something one by one instead of doing it simultaneously, approaching something at once. So the most important thing is the way you approach these questions. Let us consider the following expression. We're supposed to simplify this fully without the use of a calculator. Our answer is not supposed to contain negative exponents, and it's not supposed to have bases that are irrational. So the first thing that you do here is express 64 as an exponential prime factor. So 64 can be expressed as 2 to the power 6, 2 to the power 6 raised to the exponent of negative 2 over 3. Normally we're supposed to change this exponent of negative 2 over 3 into a positive 1, but since 64, 2 to the power 6 is a whole number and it's a base, not a fraction, we cannot do that. We can try by making it a fraction, which is 2 over 1, but it will be a long process. So the shorter version, it's if you have a base raised to an exponent with an exponent outside the brackets in a form of a fraction, you will divide the exponent of that base with the denominator of the exponent that is in a form of a fraction. So here we're going to divide 6 with 3. So 6 divided by 3, it's 2. So we'll have 2 to the power 2 raised to the exponent of negative 2. This is what we now have. 2 multiplied by negative 2. We'll use the third law of exponent, which is raising a power to a power. We'll have 2 to the power negative 4. So we're told that our answer is not supposed to contain negative exponents. We know that 2 to the power negative 4 can be expressed as 1 over 2 to the power 4. We are simplifying fully, so we need to express 2 to the power 4 in its normal form. So 2 to the power 4 is the same as 16. So our final answer is 1 over 16. 2.1.2, let us consider the following expression. So we need to simplify this expression to its fullest. We have 3 to n plus 1 minus 9 n minus 1 over 2 multiplied by 3 to n plus 1. So this is an exponential expression in a form of a fraction that we gotta use the exponential laws to answer it and simplify it further. So the first thing that you want to do is separate the exponents that are expressed in a form of a binomial, and numbers which are not prime factors, you need to express them in their prime factors form. So 3 to n will be separated plus n as 3 to n multiplied by 3 to the power 2 minus by 3 to the power 2. This is 9 expressed in its exponential form raised to the exponent of n minus 1. This is over 2 multiplied by 3 to the power 2n multiplied by 3 to the power 1. So we have expressed everything in their exponential form and separated the exponents that were written in a form of a binomial. Now what we're going to do is multiply with brackets. So 3 to the exponent of 2 will be multiplied by n minus 1. So everything else will go back as it is. So here we have 3 to n multiplied by 3 to the exponent of 2 minus by 2 multiplied by n is 2n multiplied by 3 to the exponent of 2 multiplied by negative 1 is 3 to the exponent of negative 2. This is over 2 multiplied by 3 2n multiplied by 3 to the exponent of 1. It doesn't really matter if you show the 1 or not. Now from here, because of this subtraction sign in the numerator, you need to factorize the numerator. But the denominator, you won't have to do anything. But you can multiply the 2 and the 3 to the exponent of 1 since there's no variable as an exponent. So you'll point out the highest common factor between the numerator, which is 3 to n. There's 3 to n here and 3 to n here. So we'll take that out. Then you open a bracket and write everything else that wasn't written outside, which is 3 to the exponent of 2 minus by 3 to the exponent of negative 2. This is over 2 multiplied by 3 is 6, so it's 6 multiplied by 3 to the exponent of 2n. Now, since we have factorized the numerator, you are allowed to cancel out denominators that are exactly the same as the numerator. So 3 to n will cancel out to 3 to n. So you're supposed to show with the pencil that you're cancelling out. So this cancel out. Now in the numerator we're left with 3 to the exponent of 2 minus by 3 to the exponent of negative 2 over, this is inside the bracket, over 6. So now you're gonna show 3 to the exponent of 2 and 3 to the exponent of negative 2 as whole numbers, not in the exponential form. 3 to the exponent of 2 is 9. So here we'll have 9 minus by, since this is a negative exponent, we know that it can be expressed as 1 over 3 to the exponent of 2 over 6. Then in the following step, you'll simplify the numerator of 1 over 3 to the power 2. So we still have 9 minus by 1 over 3 to the power 2 is also 9 over 6. You have fully simplified the numerator and the denominator. So from here you are allowed to put the numerator into your calculator, not the entire fraction, or else you won't be given a mark for the final answer. So you can put the numerator, which is 9 minus by 1 over 9. It will give you a fraction which is 80 over 9. So 80 over 9 over 6. So from here you're going to turn this division sign, which is the fraction, into multiplication sign so that you're able to multiply. And the denominator will use the reciprocate of the denominator. 6 can be expressed as a fraction, so we'll express 6 as a fraction. Now we're going to have 8 over 9, which will now be multiplied to 6 over 1. But you gotta use the opposite of 6 over 1. So in the next step we'll have 80 over 9, which will be multiplied to 1 over 6. So from here you multiply the numerator with the numerator, the denominator with the denominator. 80 multiplied by 1, it's 80. 9 multiplied by 6, it's 54. It's 54. So from here you will look for the highest common factor between 80 and 54. In terms of looking for the highest common factor, there's no need for you to really think very hard, because you can get the highest common factor by using the calculator. When a question says do not choose a calculator, it doesn't really mean you mustn't choose a calculator. You just don't have to show the markers that use the calculator. So here you can say 80 is equals to shift fact, then you get 2 to the power 4 multiplied by 5. Then you note down those numbers which you got. So we got 2 to the power 4 multiplied by 5. If the prime factors of 54 contains any of these numbers, that number, those two numbers which are common, will be the highest common factor. Then it's 54 is equals to shift fact. So the prime factor of 54 is 2 multiplied by 3 to the power 3. Now we can see that in the prime factors of 80 we have 2 to the power 4. 2 to the power 4 comes from 2 to the power 1, 2 to the power 2, 2 to the power 3, and 2 to the power 4. These are the prime factors of 2 to the power 4. And this 2 is the same as 2 to the power 1. So we have a common factor of 2, which is 2 to the power 1, and this 2 to the power 1. So it comes from 2 to the power 4 and 2. So I'm going to divide the numerator and the denominator with 2. So we divide by 2, and we divide by 2. Then 80 divided by 2 is 40. 54 divided by 2 is 27. 27 and 40 do not have a prime factor, so this is what your final answer will be. 2.1.3, we have a static equation. We are required to simplify it fully. In the numerator, we have numbers enclosed inside a bracket and raised to the exponent of 2. This means that we need to expand this numerator. In the denominator, there's nothing you can do as of now. So the main focus is the numerator. Whenever you're approaching mathematical questions like this, you have to focus on one aspect first. Like you cannot try and deal with the numerator and the denominator at the same time. So in the numerator, we'll expand this bracket. We'll have 3 minus by square root of 3 and 3 minus by square root of 3, close bracket. This is over square root of 3 multiplied by square root of 6. Now from here, you're going to multiply with brackets. So 3 multiplied by 3, this is 9. 3 multiplied by square root of negative square root of 3, it's negative 3 square root of 3. Negative square root of 3 multiplied by negative square root of multiplied by 3, it's again negative 3 square root of 3. Negative square root of 3 multiplied by negative square root of 3, it's positive 3. This is over square root of 3 multiplied by square root of 6. Now from here you group the like terms. So 9 plus 3, this is 12. The other like term is negative 3 square root of 3. So when you have a root and it has the same number under the root, you just subtract the numbers that are outside the square root, subtract or add depending on the sign that is in front of them. So we'll focus on negative 3 and negative 3. Negative 3 minus 3, it's negative 6. So you'll only use one of the roots, not both of them, to the square root of 3. This is over square root of 3 multiplied by square root of 6. Because of the subtraction sign in the numerator, you're gonna factorize. So the common factor between 12 and 6, you don't pay attention to the square root of 3. So it's only 12 and 6. The common factor between 12 and 6 is 6. So you put out 6 outside the brackets, you open the bracket. 6 divided by 12 is 2 minus by 6 divided by 6, that cancels each other. So you want to represent 6 again, so the square root of 3 over square root of 3 multiplied by square root of 6. Now from here you will try to find a way in which you will cancel out the denominators. Our denominators cannot be expressed in a form of a SAD, as it will give us an irrational number, and we're told that our answer cannot be irrational, cannot have denominators that are irrational, as these numbers under a root are not a perfect square. So you'll find a way to cancel them out. Now you can see that in the numerator we have 6, and if we can multiply the square root of 6 by a square root of 6, we'll get a 6. That will be able to cancel that out. So we'll multiply both the numerator and the denominator by a square root of 6. Then in the numerator we'll have square root of 6 multiplied by 6, open bracket, 2 minus square root of 3, close bracket, over square root of 3 multiplied by square root of 6 multiplied by square root of 6, it's 6. So these two 6's will cancel out, and the numerator will be left with square root of 6, open bracket, 2 minus by square root of 3, close bracket, to the square root of 3. From here you will try to cancel out the square root of 3. So square root of 6 in the numerator and the square root of 3 in the denominator have a common factor. Their common factor is 3. So you'll divide these roots by the common factor of 3. Square root of 6 divided by 3, it's square root of 2. Square root of 2. So in the numerator, let's square root of 2, open bracket, 2 minus by square root of 3. In the denominator, since the common factor is the same, it will cancel out. We'll be left with 1. Now, whenever a number is divided by 1, it's the same as you're dividing it by itself. So we'll still have 2. Our final answer will be 2 square root of 2, open bracket, 2 square root of 3. Your final answer can have a root if it's not a fraction. If this was a fraction and these roots were the denominator, then that was not going to be the final answer. You're not going to get the marks. But since this is not a denominator but rather a numerator, as it will become a base, a number by itself, you're allowed to have a SAD as your final answer. 2.2.1, we're expected to solve for x. We have x square root of 32 is equals to 128. So the first thing that you gotta do when you have an equation like this is express the square root in a form of an exponent. Now how do you express a square root in a form of an exponent? To make an example, square root of 2 can be expressed as 2 to the power 1 over 2. That's how you express square root of 2 as an exponent. Cube root of 2 can, in a form of an exponent, can be expressed as 2 to the power 1 over 3, and so on. So we need to express x and with the square roots in a form of an exponent. So it can be expressed as, okay, it can be expressed as 32 to the exponent of 1 over x, which is equals to 128. Now that we've got to this point, we need to express these two numbers in their exponential form. So 32 can be expressed as 2 to the power 5. This is all raised to the exponent of 1 over x, which is equated to 128 can be expressed as 2 to the power 7. So when you get to this point, you want to multiply with brackets. So multiply the exponent of 5 with the exponent of 1 over x. So normally we're supposed to divide 5 with x, but since 5 is a variable, we cannot do that. So we'll make 5 a fraction, then we'll multiply 5 with the numerator of the exponent, which is 1, and 1 with the denominator, which is x. So when you make 5 into an exponent, you'll have 5 multiplied by 1 is 5, and 1 multiplied by x is x, which is equals to 2 to the power 7. This is what we now have. So since the powers are the same, the bases are the same, we equate the exponent. So on the left hand side, we have 5 over x is equals to 7. So since this side, the left hand side, we have a fraction, we'll make the right hand side to be a fraction. So this will be over 1. 5 multiplied by 1, it's 5, and x multiplied by 7, it's 7x. We're solving for x, so we have to get rid of the coefficient of x, which is 7. So we're going to divide by 7 and divide by 7. Now x is equals to 5 over 7, and this is the final answer. 2.2.2, we have a trinomial and it's equated to 0. The first thing you should realize when a trinomial or a binomial is equated to 0 is that you are required to factorize and get two values of the variable that is included into that trinomial. So here the problem that you face first, it's x being raised to an exponent of 1 over 2 and 3x being raised to an exponent of 1 over 4. How do you factorize a trinomial like this? It's exactly the same as the normal factorization. In the normal factorization, normally the first term, it's always x squared. Now when you factorize this, you obviously open two brackets, then you separate the x squared 2 times, but without the exponent of 2. So x multiplied by x, it's half of x squared. So even here we need to do the same. So here instead of x and x, since it was 1 over 2, we'll have x to an exponent of 1 over 4. Even the other side, it will be x to an exponent of 1 over 4. That's the first thing that you should note down. So you'll open two brackets for factorizing, which are equated to 0, x 1 over 4, and this side x to the exponent of 1 over 4. Now you look for two numbers, when you multiply them you get a 10, and when you add or subtract them you get a 3. Now you should consider the signs when you're doing so. You have two minuses, meaning that one of the numbers will be an addition, one of them will be subtraction. The biggest number always takes the sign in the middle, and the sign in the middle is minus. So we know here there will be a minus, and here there will be a plus. So 5 multiplied by 2 is 10, and 5 minus by 2 is 3. So here there will be 5, and here there will be a 2. This is what you now have. Now you equate every bracket to 0. So x to the exponent of 1 over 4 minus by 5 is equals to 0, or x to the exponent of 1 over 4 plus 2 is equals to 0. Now from here you transpose as usual. X to the exponent of 1 over 4 is equals to 5, or x to the exponent of 1 over 4 is equals to negative 2. Now when you get to this point, you'll be solving for x. We're solving for x, not for 1 over 4, so we cannot leave our answer like this. So you will manipulate your exponent of 1 over 4 in such a way that it becomes a whole number. You do so by multiplying it with the reciprocate of what that exponent is. So here we have 1 over 4, so we multiply 1 over 4 with the reciprocate of that, which will be 4 over 1. So in the next step you'll have x 1 over 4, it will be multiplied to 4 over 1 Whatever you do on the left hand side, you do it on the right hand side. So 5 will also be multiplied to 4 over 1. So now you have x to the power 1, which is exactly the same as x, is equals to 5 to the power 4. Now in the final answer, you'll have x is equals to 625. Now for the second value of x, just since we have gotten a negative number on the right hand side, you should be able to realize that we won't be able to get the value out of this, because just think, if you can substitute a negative number to these values of x in our initial equation, then our answer won't be equal to 0. A negative number raised to an exponent of a fraction will always be equal to a negative number. So that negative number subtracted by a negative 3x with another exponent of a fraction minus by negative 10 won't be equal to 0. It will be equal to a negative number. And our answer is supposed to be a 0, as our initial equation says. So you can conclude, without even going further, you can conclude that x cannot be equal to negative 2. And this is the final answer for this question.